Hey everybody, and welcome to DirectX 11 Tutorial 61. In this tutorial we are going to review how to use the Stencil Buffer. So if we go to our graphics header, we will see that we have something called the depth stencil state. If we go to our graphics CPP where we initialize it, you will see that we create a 2D texture for our depth stencil, and we are using 24 bits for the depth and then 8 bits for the stencil. Now we know that the depth is used so that, objects closer will get drawn over objects that are further away. However, we have not reviewed what the stencil is or how to use it. Currently, in our depth stencil state, we are passing the depth test as long as the pixel that we are drawing has a depth value that is less than or equal to the existing value. So, pretty much as long as the new pixel is closer than the existing pixel, then we are overriding it and it passes the depth test. However, we're not putting anything for the stencil test here. Let's look at the default depth stencil description that gets made from the D3D11 struct. We're going to press F12 to peek into this. And if we look at the default, we'll see depth enable is true, which that makes sense for what we're currently doing. The depth right mask is all. The depth function is D3D11 comparison less, which we use less or equal, but they have similar functionality. The only difference is less will not replace if the depth is exactly the same. You'll also notice that by default the stencil is disabled. The read mask and write mask are set to the default read mask and write mask. So the default is 0xFF, which makes sense because 0xFF is 255. And 255 is the max value that you can represent with 8 bits. And we're using 8 bits for our stencil. If we have a read mask of 0xFF, then it will not have any effect when we mask our value with it. Because any value masked with 0xFF will be the same value. For example, if I have 1 and I mask it with 0xFF, it's still 1. And this is the same for any value that can be represented with 8 bits. We're not going to get into anything where we would actually modify the read mask or write mask, so we're still just going to use that default value. Now you'll see we have a stencil operation description for the front face and the back face triangles. We're only concerned with the front face triangles because we're not rendering back face triangle. And in this example, they use the same stencil operation for both. However, it doesn't really matter because the stencil is enabled here. So what we're going to do is, let's first create a new depth stencil state and look at the documentation and see how our stencil will operate. So let's go up to the graphics header. We are going to create a new depth stencil state, and we're going to call this draw mask, because this is going to be for when we are drawing the mask for our stencil. Now let's go to the graphics CPP, and we are going to create this. Let's see. And there's a few things we're going to change. So, first off, when we draw the mask, we're not actually going to be concerned with the depth. So let's go ahead and just disable that. So we'll do depth stencil description, depth enable equals false. Next, if we go back to this, we don't care about the depth right mask or depth function because we just disabled depth, so we can just completely ignore those. We need to change stencil enable to true because we do want to enable the stencil. So we'll do depth stencil description. My bad. We're actually doing it for the draw mask depth stencil. Stencil enable set to true. Next, we are going to keep the same read mask and write mask. Like I said, we won't be touching these for now. And next, we need to look at the front face and back face depth stencil operation descriptions. So let's go back and let's take a look at the documentation. In the documentation, if we take a look at these structures, we'll see a few things. So the first member is the operation to perform if the stencil test fails. The stencil test will be determined by the stencil function. The next argument is the operation to perform if the depth test fails on the stencil value. The third member is the operation to perform if the stencil test passes. So let's take a look at a few things. First, let's go to our code. And we know we don't care about the back-facing triangles. So what we'll do is we'll do depth stencil draw mask, and we will do backface stencil function equals d3d11 comparison function never. So what this is saying is never, do any kind of comparison for the back face. We're just never going to do that. And also, we'll just go ahead and set the back faces operations to all be keep. So the idea here is the stencil function for the back face will never get called. But we're just go ahead and saying if it did ever get called, which it shouldn't be for this, but if it does, we're just going to keep the current value so no changes made. Now, more importantly, let's take a look at the front face. And for this example, we are going to do always. So this is saying the stencil function for the front face triangles will always pass, so we are always going to perform this pass operation. For the fail operation, we can just put keep. And for the stencil depth fail operation, we can also put keep, but keep in mind that these should never happen because of the fact that our function here is set to always. Next, we have to determine what to do on pass, because we're always going to pass with this stencil function. So what do we want to happen to that specific pixel when we pass? Well, let's take a look at how this will operate. So we have the option between increment and saturate. There are, of course, other options, but we're not going to look at those just yet. So if we take a look at increment, here is how increment will operate. I have this 8x8 grid, so assume each of these spots is 1 pixel. So we have 8 pixels by 8 pixels. Keep in mind that when we first begin our new frame, we are clearing the depth stencil view, and we are initializing all the stencil values to 0. You could initialize them to something else, but we are initializing them to 0. Because of this, our initial value for all of the pixels in our stencil buffer for this stencil will be 0. What if we drew a blue rectangle? Using the current depth stencil state that we just created, we would now have these values, because all of the pixels that were drawn to had their value incremented, and they were drawn to 1 time. If we drew another rectangle, so this pink area, then the values would change once again. Now, as you can see, the pixels that were drawn to twice will have a value of 2, while the other pixels will have a value of 1, and then the pixels that were never drawn to will have a value of 0. So you may be wondering, okay, that's how increment works, But what's the difference between increment and increment saturate? Well, let's take a look at another example. Let's assume that our pixel values are all at 254. Whether we initialize them to 254 when we clear the depth stencil, or maybe this pixel has been drawn to 254 times. And then when we go to draw our blue rectangle, these values will change to 255 inside of the blue rectangle. And if we draw the pink rectangle, these values will change once again. However, you see the values return to 0 because we cannot represent 256 with 8 bits. So it just looped right back around to 0. Because of this, we will use the increment and saturate pass operation. And what this will do is, instead of going to 0, we will add our blue rectangle, and we will go to 255, and we will add our red rectangle, or pink, whatever, and then we will still be at 255, because this is clamping it to the max value. One other thing to note is that in this comparison, we're using always, so we're not actually doing a comparison. But if we were doing some kind of comparison here, let's say we were doing greater or less, etc., the value that is being compared is the value when we set the depth stencil state. So one of the arguments for this function is stencil reference over here. So we have 0 being passed in there, but you could pass in any value here, and that's what would be used for that comparison. We're going to change that back to always. Alright, and let's take out that old code. Let's go back up to where we were drawing the sprite. And what we are going to do is we're just going to say device context, set depth stencil state. We will pass in this new depth stencil state that we just made, the stencil reference of 0. And one other thing is I want to move the sprite to the middle of the screen. So I'm going to do that in the initialization down here. So let's go ahead and do sprite.set position. And for the position, we will have, let's see, we want it to be in the middle. So we will do the window width divided by 2. But then we have to offset it by half of the sprite's width. So minus sprite.getWidth divided by 2. And then for the height, do window height divided by 2 minus sprite get height divided by 2. And for the z, just pass in 0. So now that should be at the center. Let's go ahead and debug this and see what it looks like. So you'll see our sprite is being drawn in the middle of the screen, and since the depth is disabled, it is being drawn over everything. However, even if it was enabled, it would still be drawn over everything because we have a value of 0, which is as close to the camera as it could possibly be. However, what if we wanted to draw this sprite and then only draw the 3D objects that are actually within this sprite? So we're using the sprite like a mask. What we could do is we could create a new depth stencil state. We'll call this apply mask, because in the first one that we made, we were drawing the mask, and then this one we are actually applying that mask that we drew. So let's go ahead and initialize our new depth stencil state. We'll go to the graphics CPP and go up to where we initialized the other ones. What we're going to do is just copy and paste what we had for the draw mask. I'll set this up for the apply mask. So what we're going to do is, for our comparison, we're going to do less than. And the idea is we will have a stencil reference value of 0. So for these pixels, if we go back to our drawing, so for these pixels, the ones that the mask drew to will not have a value of 0. So we'll only pass the test if this value is greater than 0, since we're checking if the stencil reference is less than the existing value. So we'll have less, and if we do pass, we'll just keep, we don't really need to increment it or anything, since this is just when we're actually applying the mask. And I just need to update these variable names. Alright, let's go back up to where we are drawing. And something else is we will have to draw this 2D sprite first. Let's go up here and draw that. Now, we will have to move where we are setting the vertex shader, pixel shader, input layout, and depth stencil state, because the 3D drawing uses a different version of that. So let's just move these right down here. So we are going to now use the depth stencil state for applying the mask. And if we test this, let's see what this looks like. Alright, so we see hello world. We don't see our object. Okay, the reason that we were not seeing the object is because down in the draw mask, the first depth stencil that we just created, I had back face here instead of front face. So it did not have the correct pass operation where it was supposed to increment the stencil value. So that should fix that right there. Now when we test it, you will see that we will see our 3D object inside of this. Now, there's one thing you might have seen right here, I just realized, is the depth is not enabled. So I want two things. First, I want to copy the comparison function I was using before, put that in here. And then I want to take off where I was disabling the depth. And now when we test this, it should look normal. Let's see. There we go. Yeah. Everything looks good. And in the background, we have our hello world. Now, in the next tutorial, we're just going to look at some other things that we can do using the Stencil Buffer.